I don't know if I'm recording. I think I'm recording. Yeah, I'm recording. Cool. What up, Precalc students? We're seeing what the graph of these trig functions look like. Really quickly, we saw graph is in a circle. The circle is what we use to understand the trig function being the ratios of, SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse. If we're talking about a unit circle, our triangles always have a hypotenuse of 1. So we're just really about the opposite side length of the adjacent side length, the vertical displacement, the horizontal displacement. And, we understand like the sine of 0 is 0. We understand the sine of pi values. Understand that pi values are just numbers, like pi over 3 is very close to 1. We know that the sine of pi over 3 is root 3 over 2. So I can plot the point, root 3 over 2, which is 1 on the x-axis. Pi over 3, which is close to 1 on the x-axis, plots the y-coordinate root 3 over 2. Root 3 over 2 being close to like 3/4, it's like 1.7 divided by 2. It's actually like 0.88. And if we continue, we know like pi over 2, which is 3.14 divided by 2, which is close to 1.5. So on the x-axis, close to 1.5, our sine value, our y displacement, is 1. So we have this point, 1.51. And we can see, if we think about in our unit circle, SOHCAHTOA, opposite always being vertical, hypotenuse always being 1, that it's just this y distance. And it's for any angle. It doesn't have to be a 30, 60, 90 triangle or 45, 45, 90 triangle. The y distance is shrinking right now until we get the sine of pi. So this is close to 3 on the x-axis. Pi is close to 3. The sine of pi is 0. So I have this point 0. And if we continue to go into the third quadrant, when I'm plugging in bigger angles, x is 4 pi over 3, 7 pi over 6. Well, we see that the vertical displacement is now negative. This is the idea of like the opposite having a negative length. So we plot these negative values. And we create this period of a graph. This graph that goes up, maxes out at 1, because the sine's maximum value is 1 at pi over 2, minimum value at -1. And then if we kept going, the circle repeats. We talk about coterminal angles. The sine of 13 pi over 6 is the equivalent to the sine of pi over 6. I would be going over here now at 13 pi over 6, and I would plot the point over there. So like I'm going to continue to go around the circle, and when I continue to go around the circle, it doesn't really trace over this graph. What it does is it just continues to repeat the same values. Conversely, if we go in the opposite direction, we could go to like negative pi over 3, go to negative pi over 3, negative pi over 2, and the x values would produce, the same y values, just going in the opposite direction. So this is the graph of sine. This is what's called a sinusoidal function. It's got waves, and it's got very specific characteristics of it. So here's how we're going to graph it. We use this kind of box method because it makes it easier, where we pay attention to the midline. We know like the sine of 0 is 0. So I'm going to put like my starting point 0 here, and I'm going to put my midline, like the middle of the graph that I see. The middle of the graph is y equals 0. Sine starts at 0, 0. We'll eventually get to a maximum of 1. Come back to 0 at pi. Go to a minimum at 3 pi, minimum of -1. And get back to where it started when it gets to 2 pi. Now these are x values. What are some of the important points in between? Well, we kind of know what they are, and I'll talk about how we get them if things change. But they're in pi over 2. So it's kind of like we take our graph, which creates a period, which is 2 pi. We divide it by 4. 2 pi divided by 4 gives me like my x step. Okay, and this is the graph of sine. I have a period of 2 pi. My amplitude, which is the distance from my midline to the top or the bottom, this is a positive value always. We're going to say it's a positive 1. I go up 1, I go down 1. That's my amplitude. My phase shift is like a horizontal shift. There's no phase shift and there's no midline shift. Cool? And we'll talk about if we have transformations, what that would look like in terms of the words period, amplitude, phase shift, midline. If I have the graph of cosine, the difference is we are talking about the x distance. Well, we know that the cosine of 0 is 1. So I'm going to start at this point 0, 1. I know the cosine of pi over 3 is a half. So if I go to pi over 3, I have this x distance a half. We notice that the x distance starts at 1. It decreases. When I get to pi over 2, the x distance, the adjacent distance, start over. The adjacent distance is 0. When I get to pi, the x distance is negative 1. When I get to 3 pi over 2, this blue line, this x distance decreases and gets to 0. And then as I go from 3 pi over 2 to 2 pi, we go back to positive values and boom. And again, this graph continues to repeat as I continue to go around the circle. And if I go backwards to negative angles, we'd have the same values. So this is the graph of one period of sine. Again, it repeats itself when I get around the circle. So the period is like, how long does it take for it to repeat itself? 2 pi. The amplitude is still 1. Phase shift and vertical shift is 0. We kind of start with this. This helps us identify our midline, where we start, where we're going to end 2 pi later. We take that period, we divide it by 4, and we realize like each important step along the way will be a pi over 2 away from each other. We have an amplitude of 1. I go up 1, I go down 1. But remembering the cosine of 0 is 1, I start at this point 0, 1. I go down to the middle, the cosine of pi over 2, the cosine of pi, the cosine of 3 pi over 2, the cosine of 2 pi. And this is what the graph of cosine x looks like. It's not a circle. It's something that repeats as I continue to go around the circle, coterminal angles, repeating x distances, y distances, understanding that the trig function of an angle is always equivalent to the trig function of the reference angle creating our triangle. Okay? Now, let's think about y equals a f of bx plus c plus d. We know a is going to be a vertical dilation, where you're going to take your y's and multiply them by a. D is going to be a vertical translation, where you'll take your y's and you'll add a certain number. C is a horizontal translation. It's going to be opposite of what we think we're going to do. We're going to add or subtract our x's, opposite of what we think. And B is a horizontal translation, which will take our x's and we'll multiply them by the opposite of what we think, or we're going to take the inverse. So it's like we'll divide them by B. And if we think about that with our graph of sine or cosine, let's get the traced again. If I take all the y values and multiply them, what we're going to do is we're going to increase the amplitude. So A values which take your y's and multiply them will change your amplitude. Okay, so I start with an amplitude of 1. Here I have this A value of 2. My amplitude becomes now 2. Cool. What else do we have? We have this D value. This D value takes all of your y values and adds them. It's not multiplying. Now multiplying takes 0 and keeps it 0. Takes 1 multiplied by 2 makes it 2. But if I take all of these y values and add a value, it's going to shift things up. That's going to adjust the midline. So our midline or our vertical shift is now going to be at 3. Cool. We can start graphing right now, just paying attention to our y's first, and then we'll do our x's later. My midline, my vertical shift, I'm shifting from y equals 0 to y equals 3. I will be going up and down 2 from there. Amplitude of 2 takes us to 5 and takes us to 1 if I go up 2 and down 2. Cool. Now let's pay attention to our x's. Now, here's the key. The period for a normal equation is 2 pi. Now, if I have a b value, it's a horizontal dilation. It's going to affect these x values that it would take to repeat. Well, what is this horizontal dilation going to do? Well, it's not going to take your x's and multiply them by 2, but you are going to take these x's and multiply them by a half. What happens is we will take our period of 2 pi, multiply that by a half, and realize, oh, my period of this new graph is going to be pi. And I'm going to go to Desmos to show you. So what you end up doing is realizing, because of our understanding of horizontal dilations, that you're going to be dividing by this b value. Because the horizontal dilations are inverses, it will kind of like reverse things based on what we expected to do. And we get this idea. I will take my period, which is normally 2 pi, I will divide it by 2, and my period of this graph is now pi. There's no phase shift, there's no horizontal translation here, there's no c value. So here comes the x's. I'm going to start at x equals 0. I will get to one completed period after pi. Now, each step along the way will be this period length divided by 4. So I'm going to kind of put this on the side and say steps are going to be my period divided by 4. Here it's going to be pi over 4, so this would be pi over 4, pi over 2, 3 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, pi. And then we pay attention to what trig function do we have. We have sine or cosine. Well, sine starts at the midline. If I plugged in 0, I'd have the sine of 0, which is 0, times 2 stays 0, plus 3. I start here. Sine values as I go around the circle will go up to a maximum, back to the middle, to a minimum, back to the middle. And this would be the graph of 2 sine 2 x plus 3. Now, what's important to realize is what we have here is the graph, but it's shifted off of the x and y axis. This, I could say, is x equals 0. That makes sense. This is y equals 0. Here's your x-axis. So I've taken the graph that's normally taken. I'm going to graph it on this box, but this box, by me labeling things correctly, helps me with the shift so that we're not going on a negative 10 by 10 axis. Let me just show you like what we did so that it makes sense to you, hopefully. We'll go y equals 2 sine, is it 3 or is it 2? 2 sine 2x plus 3, okay? I looked at the one cycle between 0, x equals 0, and x equals pi, 3.14. Right here is x equals pi. We could see we hit a maximum of pi over 4, 5. We'll come back to the middle at pi over 2, which is about 1.57, 3. We hit a minimum at 3 pi over 4, 1, and we come here. So like this graph that you see here is this graph. It's just like I'm going to sketch it on the box and then understand where it falls on our x's and our y axes. Okay, cool. All right, what would happen if I don't graph sine, but I graph negative sine? if all of a sudden I make a negative sign? Well, all the y values are just going to flip. It's going to be a vertical reflection. If I have cosine, which cosine of 0 starts at 1, if I take the opposite of it, it's a vertical reflection. So remembering vertical reflections are still going to be occurring, and they could occur with trig functions. Here we go, and let's pick out the important points. We have a vertical dilation, which will affect our amplitude. I'm also going to pay attention to a vertical reflection, which is this -1. We have our adding outside of our function, which is going to be a vertical translation. So our vertical shift, which will affect our midline, now goes down to pause. I've taken care of the y's. Let's do some work. My graph will kind of have a midline at y equals -2. I will go up 4 and down 4. Okay, done with my y's. Now let's talk about my x's. Well, I have this pi here. This is our b. Now again, our period starts with 2 pi as a normal graph. Our normal sine x and cosine x graph is a 2 pi period. My vertical dilation is by a factor of 1 over pi, or I will take my normal 2 pi period horizontally dilated by this factor of b, and I have 2 pi over pi, and I get a period of 2. Okay. When I plug in 2, I get 2 pi. Oh, I've gone around the circle. Okay, it's like I could have done that here. When I plug in pi, I get 2 pi as my angle that I plug in. I've gone around the circle. So again, it's kind of that inversing of things that we've talked about before the end of the semester. So no phase shift, there's no C value. So I'm going to start at x equals 0. This is all my phase shift. I will go to a period of 2. My steps that I'm going to take is this 2 divided into 4 pieces, which means I have a step of a half. So I have a half, 1, 1.5 as my x values. It's cosine. Cosine of 0 is 1, but I'm vertically reflecting it, so that 1 becomes a -1. Then I'll hit the cosine of pi over 2. Then I'll hit the cosine of pi, but vertically reflected, the cosine of 3 pi over 2, the cosine of 2 pi. This would be the graph. But what happened is I have the actual y-axis located somewhere right here. Between -2 and +2. My x-axis is still right here. So this is kind of what the graph would look like on a normal x-y axis. I'll kind of show you that. We want you to do this without graphing, but it's always good to check. Cosine 4 pi x -2. Okay, notice pi made the period, which can be from a minimum to a minimum. You can kind of see my period is 2. I get back to where I started after 2 x's. What are some of the points I see? 0, 6. Here's an easy point. I could find 1, 2. I have the point 1, 2. I have the point 2, -6. In between along the way, I'll have the point a half, 0. Oh, sorry, a half, -2. I'll have the point 1.5, -2. I'm just looking at this one period of this graph. Obviously, the graph continues on forever and ever, but this gives you an idea of like what it would look like and how we can repeat it. We can go backwards, we can go forwards. I can go to 2.5, I can go to -0.5, -1. I can keep going and continue to repeat my graph. All right, now we got A, B, C, and D. So let's start with our Y's. I got 2, again, for my A. That's a vertical dilation. Vertical dilation of 2 means I'm going to affect my amplitude. I'm going to multiply my y's by 2. Great. I have a Vertical translation, that's going to affect the shifting up and down of my graph. That's going to affect the midline. We call a vertical shift a midline, so make sure you just kind of understand that. It should have been in your homework. Cool, so let's do that. Vertical shift of 2, my midline goes to 2. Amplitude of 2, up 2, down 2. I will go down to a y equals 0, and I'll go up to a y equals 4. Now let's pay attention to our x's. Either one you could start with. Phase shift is shifting things to the left and to the right. We see our horizontal translation, understanding it's like inverses, inside, undo. We are going to go to the right 3. Okay, so I will start at x equals 3 as my starting point if I'm taking my starting point of 0, 0, and then shifting it to the right 3. That's going to be my starting x value for one period. Now my period, okay, pi over 4, that's a horizontal dilation. You'll take your x's and not multiply by pi over 4, but divide by pi over 4. Again, you're going to take your normal period of a sine graph, horizontally dilated, not by multiplying by the value, but by dividing by the value. Now we understand that dividing by pi over 4 is the exact same as multiplying by 4 over pi. So if I see like pi over 4, I know, oh, you're just going to take your x's and multiply by 4 over pi. Again, inverse undo. What we find is the pi's cancel and we get our period for this graph is 8. I have to plug in 8 more to get an input of 2 pi. Let's think about this. 3 plus 8 gives me to 11. This is going to be a common mistake students are going to make. They're going to think that this number here goes to 8, but it's not. It's got to be 11 because every step along the way should be a step of 2. If I split this period into 4 steps by dividing by 4, I'm going to add 2 to 3 to get 5, add 2 to 5 to get 7, add 2 to 7 to get 9. Okay, now let's think about this. If I plug in 3 minus 3 is 0, boom, I got the cosine of 0. I'm going to get 1 times 2 plus 2, 4. There's my starting point. What if I plug in 11? Again, this is why it's all about undoing with inside. 11 minus 3 is 8. 8 times pi over 4 is 2 pi. Oh, I'm plugging in the cosine of 2 pi. I've gone around the circle completely. I'm starting over. So that's why I'm going to be back to where I started. You could check, plug in your values along the way, and you should see 0, -1, 0. Well, it's not 0. It would be 2, 0, 2, 4. Okay, what did I do? I shifted my x-axis to the right, so it's really like I'm starting here, and I have this y-axis here. Continue on. If I graph this, you'll be able to see the period that we sketched. 2 cosine pi over 4 x minus 3 plus 2. Okay. Where did I start? I started at 3, 4. 3, 4. Boom. Right there, I got it. There's the beginning of the graph that I just sketched. I hit a minimum at 7, 0. 7, 0. Bam. I hit a maximum back at 11, 4. My period, 3 to 11, is 8. Cut it in half. Boom. 11 to 3, we get 7. Cut that in half. We get this 5, 2. We get this 9, 2. 5, 2, 9, 2. Hopefully we understand this. I'm going to start moving a little bit quicker for the last one, just so we can get through it. But this is actually a very good one. Again, let's pay attention to our y's. Amplitude is going to be 3. That's my vertical dilation. But I also have a vertical reflection. So I'm paying attention to that because I have a negative. I have a vertical translation plus 2. That's going to shift my midline up 2. Let's just do the y's. I have my midline shift, my amplitude up 3, down 3. I'm going to go down to -1. I'm going to go up to 5. Cool. Good start. If you want to graph right now, you can. Sine starts at 0. The sine of 0 is 0. So like if I plug in whatever my starting point is here, I'm going to get 0. I usually go up the sine of pi over 2, the sine of pi, the sine of 3 pi over 2, but vertical reflection, I'm going to go down. And like you have the graph right now, but what you're going to do is you're going to fit your axis, you're going to fit your x-axis to this graph. And this is going to be the trickiest one that we're doing so far, where the period and the phase shift are going to produce values that are like pi's, that are easy to plug in. So let me just talk about that. We have our horizontal dilation of 4, and we have a horizontal translation of plus pi over 4. So the horizontal translation is my phase shift. I'm going to shift to the right, pi over 4. So that's my start, pi over 4. Now let's pay attention to the period. The period of a regular graph with no dilations is 2 pi. We horizontal dilate. We don't multiply our x's by 4. We'll divide by 4. Our period is 2 pi divided by that b value. Period equals 2 pi divided by 4, and I get the period is pi over 2. Okay, that means it takes a total of pi over 2 x's to then start over. When I plug in pi over 2 more than pi over 4, I will have a value that will be the sine of 2 pi after subtracting pi over 4 and multiplying by 4. Now we have to do some calculations here where you have to figure out what's pi over 4 plus pi over 2. Well, we're used to doing this. We could change pi over 2 into 2 pi over 4. And we say, oh, okay, I'm going to end at 3 pi over 4. Cool. Don't forget that the steps along the way, we will take our period divided into 4 equal parts. Well, pi over 2 divided by 4 is the same as pi over 2 times 1/4. And I get pi over 8. Okay, now this is tricky. I need to add pi over 8. Okay, pi over 4 plus pi over 8. That's 2 pi over 8s plus 1 pi over 8. I get 3 pi over 8s. Don't believe me? Watch. We're going to go in. We could plug in 3 pi over 8. Subtract pi over 4. That'll give me pi over 4. Multiply it by 4 will give me pi. I don't want that. Hold on. Let's just watch. 3 pi over 8 I'm going to plug in here. So 3 pi over 8 minus 2 pi over 8, good, is 1 pi over 8. Times 4 becomes pi over 2. The sine of pi over 2 is 1. Okay, that's my output after plugging in 3 pi over 8. Take that 1, multiply it by -3, and then add 2, and boom, there's that y-coordinate, -1. It kind of like, it will work out as long as you understand what we learned in the first semester about all of our translations and dilations. Add pi over 8, I get to 4 pi over 8, which is pi over 2. Add pi over 8, I get to 5 pi over 8. If everything works out correctly, after I add a pi over 8, I should get 3 pi over 4. Okay, well, that's 6 pi over 8, 3 pi over 4. So, should have that there. This is trickier, but it works out so long as you understand the original graph and understand the translations and the dilations that we had. Let's just see our handiwork in action. And again, I can move my x and y axis around. -3 sine 4x minus pi over 4 plus 2. Okay, right here. Pi over 4, 2. I'm going to go y just so I can see. Boom. Pi over 4, 2. I then hit a minimum. 3 pi over 8, -1. 3 pi over 8, -1. Pi over 2, 2. 5 pi over 8, 5. 5 pi over 8, 5. 3 pi over 4, 2. Boom. We got it. If you want to graph your y-axis and your x-axis, the y-axis would fall right here. X-axis would fall somewhere right here. Okay. If you subtracted pi over 8 twice, you'd go up and then back down, and you'd get that 0. So watch, subtract pi over 8 twice. We have 1 pi over 8, 0 pi over 8. Cool. All right, now we're going the other way. We're given the graph. We're asked for the equation. But understanding that sine and cosine are kind of images of each other. If you take the graph of sine x and you take the graph of cos x, what can you do to one or the other to make them the same? Well, it's like take sine and shift it over pi over 2 in the correct direction, and boom. If I shift the sine graph to the left, pi over 2, so that's plus pi over 2, I get the cosine graph. Or conversely, if I take the cosine graph, shift it left, shift it right, it doesn't matter. Let's shift it right. You can shift it left more. Shift it right, pi over 2. Boom, it's right on top of each other. So we are going to be expected to write equations for sine and cosine for the same graph. How are we going to do this? We need to understand some characteristics. For example, what's the amplitude, what's the period, phase shift, vertical shift, etc. The period, always going to be the same for both graphs. Amplitude, always going to be the same for both graphs. Vertical shift, always going to be the same for both graphs. So, I don't know, let's start with our vertical shift. It's easy to see. I have this middle y equals 3. All right, that's a vertical shift. That's a vertical translation. That's going to be d. Cool. For both graphs. Period. Well, I can see I go up, down, and back up, and it takes me a total of 4 pi to repeat itself if I start here. We could also look at these 2 points, but I don't have this coordinate. We could look at half of the period and double it. This half of the graph is 2 pi, double it to get 4 pi. So period, 4 pi. Amplitude, I go from 3 up to 7. I go 3 down to -1. Take your top and subtract your middle. Take your middle, subtract the bottom. Take the top and bottom and average them together. Find this distance, which is 8, divided by 2, which is 4. And there's your amplitude. So boom. Let's start with the sine graph. The sine graph, I'm going to say, well, it starts here and goes up, goes down, back up. We're good. All right. Period. Amplitude is A. That's easy. Phase shift is C. Easy. Period. We're going to talk about this in a second. So let's start with the sine graph with our amplitude, sine. I'm going to hold off on B for a second. Phase shift is nothing, and then D is the vertical shift. How can we find this B? Okay, well, it's tough to kind of say, but we want to take a normal period of 2 pi and make it 4 pi. We want to take our 2 pi, multiply it by 2, so that my period becomes 4 pi. Well, what needs to be in your equation so that you multiply it by 2? You multiply your x's by 2. In your equation, you need a half. Now, maybe that doesn't make sense, but here's what's going to be crucial. Period will equal 2 pi, not times your b value, but divided by, inversed. Boom. Cool. Well, how does that work here? Well, I could easily move some variables around to say b is 2 pi over the period. 2 pi over the period, 4 pi. Oh yeah, that's the half. I want to take my normal period 2, multiply it by 2 to get 4 pi, which means in my equation there needs to be a half. Maybe that makes sense to you. This works. And it's really just our understanding of horizontal dilations and the fact that a normal parent function period is 2 pi. So I have a 1/2 here, and that will be that graph. Now, if I were talking about cosine, the period is still going to be the same. The b value is going to be the same, but I'm going to shift over pi, which means c needs to be minus pi. So I have 4 cosine because I'm starting at the top. I have my b value 1/2. I have x minus pi so that I shift to the right pi, and then I have my vertical shift 3. See our handiwork in action so we can feel good about ourselves. And if you have Desmos at home, like this is good for you to do yourself. And again, we're trusting you guys that you are using and remembering your knowledge about transformations to make really this not that bad, provided you understand the parent function and the period being the important thing. They're on top of each other. There's no distinction between the two. We have certain points pi 7. We have 0, 3. We'll have 4 pi over 3, 3. We got it, okay? If I graphed y equals 3, you could see that. 4 pi over 3, 3. We're good. Okay? So, same deal. You're going to find your period, but then you also need to find your b. So maybe throw another thing here. I don't have things in the middle. I can kind of see what it is, but like, let's look up here. I got this 0.5 and this 2.5. I go from a top to a top. So I go to a maximum value, then back to a maximum value. That's going around the circle. That's my period. That's my period of 2. I go from 2 to -1. I go from 2 to 5. That's my amplitude of 3. Now, amplitude is the A. It's the vertical dilation. Sine starts in the middle. This is fine. Cosine, it looks like I need to shift to the right 1/2. I've moved my midline up to 2, midline being the D value, the vertical shift, okay? Now we have to find B. Again, if I shift to the right, C is going to be -0.5 for cosine. What's B? I'm going to talk you through it, and then I'm just going to use like the formula, kind of our understanding. My period is normally 2 pi. I want to multiply it by something so that I get a period 2. Well, that means I'm going to have to divide by pi. So that 2 pi horizontally dilated turns into 2. When you divide by pi, what goes in your equation is pi. If I have pi in my equation, that's a horizontal dilation by a factor of 1 over pi. I'll divide by pi. If you understand that, great, you're good. If you don't, here's the ticket. Take your horizontal dilation factor. It's always going to be divided by, always going to be the inverse of what you think it's going to be. Well, conversely, your B value will be found just by dividing the period by your normal period, 2 pi. I have 2 pi divided by the period of 2 to get my B value pi. It works out whether you think about it versus with our knowledge of dilations and transformations, or you kind of go with this and don't forget about horizontal dilations, okay? Cool. So, sine A, sine B, X minus nothing, no phase shift, plus D, A cosine B, X minus 0.5 plus D. X minus C, because I'm shifting to the right C. Graph both of these, you have that graph. Okay? What if I give it a table? What are you going to do? Okay? We're told that the minimum values occur at multiples of 4. So like if you want to box this out, you got this idea, and the box might help you. where you start at 7, which is a minimum value. You hit 9, you hit 11, you hit 9, and then you hit 7. You start at 0, 1, 2, 3, 4. You got everything you need. What's the midline? Well, it's got to be 9. If our period is 4, then our maximum is going to have to be in between, like minimum 0, maximum 0, minimum. So you can understand what the B value is. B is going to be 2 pi divided by my period. B's got to be pi over 2. That will adjust things so that I get this period of 4. I've shifted my midline to 9. I start at the bottom. So we'll talk about how cosine will have a vertical reflection. Sine will have to shift over. My amplitude is 2. We can see that I go up 2 and down 2. That's my vertical dilation. So let's just write our equations. I guess like the phase shift for sine is going to be over 1. That means C is going to be minus 1. The phase shift for cosine is going to be nothing. However, cosine's got this vertical dilation because it's starting at a minimum. We know that the cosine of 0 is positive 1. We need the cosine of 0 to be negative 1, vertically reflect. I keep saying the wrong words and I apologize. So sine A, sine B, which is adjusting 2 pi to turn it into 4. 2 pi to turn it into 4. I need to divide by 2 pi, so I get 4 over pi. But like dividing by 4 over pi, 4 over 2 pi is like 2 over pi. If I want to like multiply by 2 over pi, what goes in the equation will have to be pi over 2. It's very confusing to kind of talk about, but it should make sense with our idea of inverses with inside our function and like horizontal dilations and translations, or period equals 2 pi over b. Again, dilate things, and then b equals 2 pi over the period. It's the same thing. So what do we got? B is pi over 2 for both of them. Sine, I need to shift over 1, and my midline's up 9. Cosine, I'm going to be vertically reflecting things, so I have a negative 2. I need my amplitude. The B value is going to be the same because the period's the same for both of the graphs, and I shift things up 9. Okay. Minimum values occur at multiples of pi over 2. Okay, so here, minimum, maximum. All right, let's figure out the period. The period is the distance between negative pi over 2 and 7 pi over 2. So if you want to do it, you can subtract or just figure out, oh, that's 8 pi over 2, which is 4 pi. All right, so the period is 4 pi. That means B is our normal period of 2 pi divided by that period of 4 pi. Period equals 2 pi over B. B equals 2 pi over the period. So that's a B value of a half. That's important. My midline is 5. I'm starting at a negative. I'm starting at the minimum, midline, maximum, midline, minimum. Okay, so it's kind of the same deal with the flipped cosine and then the positive sign. We're to say the cosine shift is left pi over 2, which means the C value's got to be plus pi over 2. We'll say the sine shift is plus pi over 2 so that the midline's at pi over 2. So this is at negative pi over 2 is where I'll start cosine. And then here's where the graph of sine can start at pi over 2. Okay. Vertical shift, I found D. Amplitude, A is 3 because I go from 5 to 8 and to 2. Here we go. Start with cosine. A. Flip it because we're starting at the minimum. Vertically reflect it. B, I found was a half. X. C, I'm going to the left pi over 2 to start at the minimum, so I'm going to add pi over 2. Midline got shifted up 5. Sine. Amplitude still 3. I'm going up and down and then back up, so this is a good place to start with sine. Midline is 5. B is still a half, but I'm shifting to the right pi over 2, so then I need x minus pi over 2. I can graph these because this will be fun to see our work in action. All right, let's start with this one. 3 pi over 2, 8. 3 pi over 2, 8. 7 pi over 2, 2. 7 pi over 2, 2. Negative pi over 2, 2. All right, nailed the first one. Now, guys, if you are just copying this down and you are not actually trying, it's going to be tough. You have to get used to like understanding all of the different things with our dilations and our translations and how that relates to the sine and cosine graph that has a period of 2 pi to start with. Now, horizontal dilations are going to affect the period. Vertical dilations will affect the amplitude. Shifting will affect midlines and the starting point, the phase shift. Beautiful. All right, what's the best description for cosine x between pi and 3 pi over 2? All right, well, it's like important to know what cosine looks like. If you want to use your box for cosine, great. Cosine usually starts at 1, but here it'll be 0 or negative 1 as a minimum because it's a vertical reflection. 0, 1, 0, negative 1. Again, this is a vertical reflection of the normal cosine graph, which we graphed at the beginning. This would be halfway in between. This would be halfway in between, or again, you could take your period, go by steps of 4, add pi over 2 pi over 4, which is pi over 2, and we get there. Now, the graph is not easily seen with my picture, but here, if I flip this, we can see it's like decreasing concave down, decreasing concave up, increasing concave up, increasing concave down. If it's flipped, between 3 pi over 2 and 2 pi, we are decreasing, but we are concave up. We are slowing down as we get to a minimum. Decreasing, concave up. If I flipped it, and this is the regular cosine graph, which it is here, so boom, 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 we are going to decrease concave down, decrease concave up, increase concave up, increase concave down. From 3 pi over 2 to 2 pi, we're increasing concave down. Sine starts in the middle at 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Sine of 2 pi is 0. We know these values. We're good with the last lesson, these major extreme values. Flip it. Boom, 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 boom. It's almost like I should have done these questions first as like, this is what the graph looks like. This is why it looks like it. Period of 2 pi, vertically dilated. Vertically dilations, like the inverse of what we expect. 0 to pi over 2, we are decreasing concave up. Cool. This graph has a period of 6. What's going on between 39 and 42? That's a great example because like the graph's going to continue to repeat. And if you think about that, like we could change the x-axis. This is going to be back to the starting point, and this will be 12. As we keep going in multiples of 6, we're going to keep repeating. So we'll eventually get to 36, which is a multiple of 36, and 42. Oh, great. 36, 37, 38, 39, 40, 41, 42. What are we doing? Increasing then decreasing. There you go. It's easy. Whoa, this is a period of 5. Well, then that's going to be 25. 26, 27, 28, 29, 30. That makes sense. It's just kind of like shifting things over. So if we continue to repeat, which is great about these graphs, 25, 26, 27, we are decreasing only if we start at the max here. Great. All right, these should be easy. So you should be able to do these based on what we've done with transformations in Unit 5. I got sine. Here we go. I'm going to the left pi units. Inverse, inside, undo. Going down 5 units. It's got a period of 5 pi. Okay, this is tricky. That's not B. The period is 5 pi. Again, the normal period starts at 2 pi. I'm going to multiply by some value to get 5 pi. Well, that value that I need to multiply by is 5 halves. But, again, inside ends up working out opposite. The horizontal dilations are reciprocals of what we expect. We're not going to multiply by 5 halves. We'll multiply by 2/5. Don't understand that. It really comes down to period is 2 pi over B. B is 2 pi divided by my period. It's the same. It's what are we going to, undo? Yeah, so 2 pi divided by 5 pi is 2/5. Amplitude doesn't change. We're good. This is an explicit equation for g of x. Thank you, because f of x is already defined. All right, g of x, cosine. Great thing about this unit is like the next lesson is the same as this lesson, only with real world situations. So it's like we get to just practice it more and more and more if we're not getting it just yet. The quiz is a doozy though, so get ready for it. All right, 10 to the right, which means minus 10. 2 up, period's 12. Well, B is going to be 2 pi divided by my period. If the period is 12, B's got to be pi over 6. Now, let's make sure that makes sense. My period for a normal function, sine or cosine graph, is 2 pi. My horizontal dilation is by a factor of pi over 6, right? My horizontal dilation is taking your x's, not multiplying by pi over 6, but take your x's and multiply them by, or divide them by pi over 6, reciprocal them. Well, does that make sense? Pi's, 2 times 6, 12. It works, okay? No amplitude. Okay? This is a good one. We're starting with this, but we're going to phase shift to plus pi over 6. That's right, pi over 6. It's important to pay attention to this. Like when they say values in positive and negatives. That's telling you how you're shifting, but that's telling you how you're going to kind of go in the opposite direction. Cool. Now, what does my graph look like? Because we're trying to find the first maximum and minimums. All right. I got a phase shift of pi over 6. I do have no A, no D, so 0, 1, -1. That's fine. I don't really care. I got to figure out this period. Now, 2 pi will be multiplied by 2/3. That will get my period, my new period, because my horizontal dilation is going to be not times 3/2, but times 2/3, divided by 3/2. Or my period is 2 pi divided by b. That's 2 pi times 2/3. We understand things. So that's 4 pi over 3. Okay, that's tricky. That means I'm going to start at pi over 6, and then I will add 4 pi over 3 to get where we were. Or let's step this out. Steps must be 4 pi over 3 divided by 4, or times a quarter. That means my step is pi over 3. Okay, that's easier to do is 1, 2, 3, 4 steps of pi over 3. So I got to figure out what pi over 6 plus pi over 3 is. That's 2 pi over 6, so that's 3 pi over 6. Pi over 6 plus 2 pi over 6 is 3 pi over 6. So this is 3 pi over 6, which is pi over 2. Add pi over 3. That's 3 pi over 6 plus 2 pi over 6, which is 5 pi over 6. Add pi over 3, which is adding 2 pi over 6, is 7 pi over 6. Add 2 pi over 3 becomes 8 pi over 6, which becomes 4 pi over 3, which works out. Oh. Yeah, so no, hold on. It should be 9 pi over 6. Yeah, and it is. That's 3 pi over 2. That's what I should have gotten if I took pi over 6 and added 4 pi over 3. If I take pi over 6 and add 4 pi over 3, I get 3 pi over 2, which I do. It works out great. Okay. We had to figure out these steps, and we have to use a lot of, and we'll practice this obviously, but you should try. The step is your period divided by 4. Boom. Each step along the way to get maximum, minimum, midline. It's there. Sine graph goes up, mid, down, mid. 3 pi over 6 is the maximum. 3 pi over 6, which is the same as pi over 2. 7 pi over 6 is the minimum. These are all the values. Let's see. I have to see this because it's like we did a lot of work to get that answer. Okay. Pi over 2. 7 pi over 6. Bam! All right, so let's do that again. I don't know why I say like pi over 2 is not an answer. This is the same deal where we're really focused on, the graph of a period. We're focused on the fact that I'm shifting left pi over 2. I go up, mid, down, mid over the course of whatever my period is. My period is adjusted because of the horizontal dilation. Okay. My graph is 2/3 x minus pi over 2. But whatever, that doesn't matter. Let's just focus on the period. My period starts at 2 pi. My horizontal dilation is by a factor of 3/2, or the reciprocal. I don't multiply by 2/3, I multiply by 3/2. that becomes 3 pi. This is my period. This is exactly what I did with 2 pi over b. 2 pi over 2/3 makes sense. Horizontal dilations, I'm not going to multiply by 2/3. I'm going to divide by 2/3. Cool. Now, the step. Take my period, divide it into fourths. Period divided by 4. 3 pi over 4. I will add 3 pi over 4 times. I have to do some calculations. Minus pi over 4 plus 3 pi over 4. Well, that's minus 2 pi over 4 plus 3 pi over 4, which is positive pi over 4. That's my first max. Yeah, I kind of wanted this to be a cosine graph, I think, so that I couldn't tell you that this was the first answer. But we're doing what we need to do. Okay, add 3 pi over 4. It's 4 pi over 4. 4 pi over 4 is pi. Add 3 pi over 4, it's 7 pi over 4. Add 3 pi over 4, it's 10 pi over 4. And that's my graph. My minimum's at 7 pi over 4. It should be x plus pi over 2. That was my mistake. Pi over 4, 1. 7 pi over 4, negative 1. Is this the last question? Oh, we did it. That's great. All right. I'm going to start at pi over 3 because I phase shift to the right, pi over 3. My equation after shifting will be sine 3 x minus pi over 3. I messed that up on the previous one, but whatever, it didn't matter because we focused on the period and our steps. Okay. Period's normally 2 pi. But I got a horizontal dilation by a factor of 3. Horizontal dilation, not by a factor of 3, but a factor of 1/3. So take my period, multiply by 1/3. That's P equals 2 pi over B. Boom. There's my period, 2 pi over 3. What is the steps along the way? Well, plus 2 pi over 3 is actually easy to do. I will end at 3 pi over 3, which is pi. If I want to step it out, which is good for this question, I got to turn this into fourths. It becomes a pi over 6 step. So each step along the way, I add pi over 6 4 times. So I start with 2 pi over 6's, which is pi over 3. I add a pi over 6. I'll just write it as 3 pi over 6, 4 pi over 6, 5 pi over 6, pi. Cool. Sine. I wish I started with cosine, but whatever. Oh, bigger than pi. Whoa, hold the phone. Let's keep going. We start sine. I wish I paid attention to this. I stepped too much. And we are back. Oops. We're back to where we started. Here at pi. You could keep going to the right if you want to and keep stepping out. Why don't we do that? Instead, like we could just say, oh, this is going to be coterminal. It'll be the same output as pi and then keep stepping for the same graph. Or, like if you want to understand that we're not limited to just one period, we can keep going, like keep adding pi over 6. 6 pi over 6, 7 pi over 6. That's like the same as here. 8 pi over 6, 9 pi over 6, 10 pi over 6. Simplify them later, but like if you're adding pi over 6s over and over and over again, like let's just keep it unsimplified. We repeat. So like 8 pi over 6 will be like producing the same value as 4 pi over 6. 9 pi over 6 is the same as 5 pi. Like I could have just add the period of pi. What was the period? The period was 2 pi over 3. Yeah. Keep adding 2 pi over 3. And I'll show you that way too. It's really important for you guys to like make sure you remember what sine looks like. I think we'll go over it in a lesson a lot. It's like, why does sine start at 0? Why does it go up first? Why does it max out at 1? Why does it min out at -1? Anyways, after pi, 7 pi over 6 and 9 pi over 6, which is 3 pi over 2. We could have said here and here are our max and minimum values. Add your period of pi over 3. Add your period of pi over 3. That's adding 2 pi over 6. 2 pi over 3. Your period is 2 pi over 3. Add your period, which is 4 pi over 6. 3 pi over 6 turns into 7 pi over 6. Again, if you go a period length, you kind of repeat. You're back to where you started. Add 7 pi over 6 to 5 pi over 6. It's 12. 5 pi over 6 plus 4 pi over 6 is 9 pi over 6. Other ways to get your answers, regardless. You got to understand where the graphs come from. You got to make sure you could do this. That's the start. You got to understand that it continues on forever and ever and ever because the unit circle obviously like repeats. Trig of an angle equals the trig of a reference angle. We will always go back to these coterminal angles. We will have the same values. Cool. We understand from unit 5 all of our dilations and our translations. We understand that our x translations and dilations end up being inverses of what we expect. If we have a b here, we don't multiply our x's by b. We take our x's and divide them by b. We understand that a period of a normal graph to go around the circle is 2 pi radians. Well, if you have a horizontal dilation, you will adjust that period. If you have a horizontal dilation of b, you will take your period, 2 pi of a normal graph of sine, and you will dilate it by dividing by b, doing the reciprocal of what you think you should be doing. Horizontal translations will shift our starting points, making sure you know that cosine starts at 1 because the cosine of 0 is 1 instead of horizontal distance. We know A being a vertical dilation is going to adjust my amplitude, how high I go off of my midline. You know D is going to shift the center of the graph. And that's it. It's really, I think the period is tough to understand and it involves, I think understanding where the graph comes from is tough, but I hope that we're okay with things. And I hope that you understand the idea of that if we always hit like midline max, midline min, midline, like 90 degrees, pi over 2s, that we could take our period, divide it by 4 to split it into these 4 important key points of our graph. And that's what I'm going to try to get across to you in your lesson. I'm really just talking to myself right now because I'm about to teach this lesson. And I feel like you guys are in better shape than any other pre-calculus student that I've taught this lesson to. I just want to make sure I get it across well. So we'll find out. See you out there.